Hi, my name is Mark Flamer, and this is an overview of the process that I used to perform the analysis and design of the structural system on the Arboleda project. I'm working in Scia Engineer, and the architect sent me an IFC file of his model of the building. So the first thing we did was we went and we imported IFC. Now in Scia, we have some options on how we import an IFC file. The most important being whether we import as native Scia members or whether we want to import the entire model as general solids. Typically, when I get a model from an architect, I'll start by importing it into general solids because the model is traditionally going to contain all sorts of additional objects that I don't really need to be concerned with. Things like floor coverings, window mullions, doorknobs, light fixtures, so on. So we'll select Import as General Solids. And here is our model. So right away you can see that this contains quite a bit of geometry. Looks like what the architect did do is he did filter down and just send us one full story of the model. So he stripped it down to just the load-bearing components for the majority of it, but he did send one full floor that we can refer back to get maybe some additional information about additional dead loads or so on. So the first thing we're going to do is we're going to use our BIM toolbox to start to convert these general solids into native Scia analytical components. Because right now, if I were to select one of these columns, for instance, we can see that it's what we call a general solid, and it has very little information associated with it. But we can use what information it does have as a way to help us filter and select and isolate the different types. So using this role property, I'm going to use our multi-select filter tool to select all objects with the role of column. And we're going to switch into our BIM toolbox. And we're going to use the general solid into beam column tool. And what this is going to do is it's going to convert these into native Scia columns. So we see that process is completed nicely. Go ahead and select one of these columns. And then if we look now at its properties, it's got quite a bit more data associated with it. Probably most importantly being cross-section type. So we'll go ahead and take a look at what that is. And we can see that it now has a full set of cross-section properties. Cross-sectional area, moment of inertia, so on. So the next step would be to do the same process, this time for the concrete core walls. So I'll go ahead and look down the top of the building, and then I'll go ahead and just manually grab these core walls. I know we're gonna use these for our lateral system. So I'll use the BIM toolbox general solid into plate wall. And once again, now we have native Scia walls. So you can see how quickly we can take this raw model from the architect and produce a nice, simplified, filtered, analytical model from it. So I'm going to jump ahead a few steps. Here's a file where I've completed that process. And we'll see that I've also added some loading conditions. So here's our floor live loading. Take a look at some wind loading in the X direction. Some wind loading in the Y direction. And then we can also, at any time, the great thing about having both representations, having this general solids model that we started with, as well as our final structural model, analytical model together is that we can always turn back on that reference layer and always refer back to the original architect's intent. So we can see here, here's the original model, both of the cladding system and of the original architecture. And we can even set the rendering to transparent for just the general solids, so we can make it very clear which is which. So now the next thing we did was obviously run the analysis and review results and do some design. So we'll navigate to the results service in Scia, and let's take a look at something that might give us some quick insight into how this structure is going to behave. So displacement of nodes, and let's look at, just for the core, displacement in the x direction under serviceability level forces. And we'll go ahead and isolate just the wall layer. And there you go. So from this point, we continued onward to make some small modifications. In some places, small modifications, in other places, large, to the structural system. But as always, it's always nice to start with some geometry as opposed to recreating everything from scratch. And that's really where Scia and Vectorworks' use of IFC was very beneficial on this project.